before we charge off and demonstrate calculation of more hypothesis tests and demonstrate how we might use them in other kinds of context of having unknown variances, what do we do when we want to have a hypothesis test on a variance, and those sorts of things. Let's just summarize the overall procedure, because at the end of the day we're going to basically be applying this kind of approach over and over and over, just in different kinds of contexts. And the procedure that you see before you here is really an amalgam of both what you see in the Montgomery and Runger text, but also breaking it out in a couple of different areas, in particular the slightly different approach that we've used here in presenting this material as compared to the text. But at the end of the day, it's really all the same set of tests. If you're a procedure-oriented person, more is better, right? So we've got just a few more steps than what you might see, but ultimately they're really the same steps. And of course, that first thing, and sometimes this is not as easy as it might seem, is just to identify the parameter of interest and define the null hypothesis and alternative hypotheses. That's, of course, a crucial step. When we're doing these for the mean, of course, usually our null hypothesis is about the true mean equaling some particular value, and the alternative hypothesis form then is going to depend upon whether or not we're interested in a two-sided thing or whether we have particular interest on one side or the other. So you see three different statements. We're not going to use all three of them at the same time. Well, I guess you could argue that this one here is really those two together. But the biggest and most important issue about defining these, besides the fact they have to be about a population parameter, not a statistic, but a population parameter, is that you need to have two exclusive events between these two. You don't have to have exhaustive events. Right? These two combined are exhaustive. But this one compared with that one, those combined are not exhaustive, and you don't have to. It may weaken the kind of conclusion that you develop, but if your interest is in a very specific kind of area, then this may work out the one-sided that is quite well. And we'll see later on with variances and that sort of thing where that does turn out to be the case, where one-sided sorts of tests are valuable and important to us. So big key here, two exclusive events and defining those two hypotheses. The parameter of interest will be strongly suggestive of the test statistics that you're going to use, and here's just one illustration of a test statistic, and here's one of the differences between the way I've articulated versus what the text is, and that is in coming up with the operating rule. And this is a more sort of general approach of, but at the same time, as well as it's general, I think it's a little bit more direct and less mysterious, that we're trying to come up with an operating rule. It's really our acceptance region, x bar plus or minus c, that if we calculate ultimately the x bar, then if it falls in this kind of region, well, then that's going to say, well, I'll go ahead and accept the null hypothesis. Right? And then we select a significance level. That's very conventionally chosen as 10, 5, or 1%. And then we use that to figure out what this value of c is. That is going to go along with essentially the probability of a type 1 error given the null hypothesis is going to be set equal to alpha. Right? Now we have looked at this in the other side of this of what's the probability of the true mean being within our region, and there then that was 1 minus alpha over here on the right. So it's the same kind of idea at the end of the day. Right? Then if you have the situation, if it's appropriate and feasible to investigate the type 2 error probabilities, that's where you would do this, that aspect of the procedure, and then you get into computations. So, and finally conclusions. And note that the differences again are that I've broken out the operating rule, and I've also inserted in here the investigate the type 2 error probabilities. That's a little different than what you'll see in the Montgomery and Runger text. When you finally get there, if your test statistic falls in the acceptance region, then you accept the null hypothesis. If it falls into the rejection region, then you're going to reject the null hypothesis at the alpha significance level that you have. Right? So that's how you're going to report this. It doesn't mean that HO is incorrect. It just means that you're going to reject it at this significance level, and that's a key aspect here. It softens your statement a little bit, but it is an important and subtle kind of distinction. from the extended example that we worked through with the asphalt content summary, here's a part of what that procedure would look like. You've got the null hypothesis, you've got the alternative hypothesis, the test statistic that we're going to use, the sample mean. If you've printed this out, you don't have this little X bar part here. In the rule form, again, you have an X, but you don't have the X bar to indicate that this is associated with the sample mean. Just a formatting issue with the software that I used. So just take note of that there. And then also you've got that same kind of little guy down here. Right, so that's just summarizing. It doesn't show you all of that work that we did in developing that example. And then finally you'll note that if you have a textbook on the inside of the back cover, if you have a hardbound, otherwise you have to go find it in the electronic form, you've got this summary table of one sample hypothesis testing procedures. And that's just to pull this kind of stuff into a nice, easy, simple reference. And so you'll see that you've got 4 different cases. There's your null hypothesis, typical kind of statement, the test statistic that goes along with that, the alternative hypothesis, and if you're using a fixed significance level criterion for rejection, there's a table for that, the p-value, how do you calculate the p-value, and then this notion of the operating characteristic curve parameter and which chart. They have a whole oodle, bazoodle number of them, A through N, N, O, P, I don't know, there's a whole lot of them. Those non-dimensional charts that are referred to in a previous little mini module. Okay, and so you'll see all that spelled out. It wouldn't be a bad idea for you to go and at least know where this is at, or even to take a blank form of something like this and complete that yourself. That's a great way to sort of summarize, crystallize this information in your own mind, or come up with your own version of this table that makes sense to you in particular. While you're doing that, you'll also note that there is a summary table for 2 sample hypothesis testing procedures, and they take up 2 pages instead of half a page. So anyways, take note that they're good resources for you to have around.